So I'm about to square off some mild steel here. And the last time I was using my mill, I had a 1/8 end mill in there, so it went pretty fast. So with a 1/2 inch end mill, I need to go slightly slower. Well, so with a round column mill, here we go. Now you got to look at your spindle rate that you want. Crack the lid open and move all those belts. Well, welcome to Let's Roger That. I'm Gilles, and today we're going to convert this King PDM-30 to VHD. Let's go. So before you get all excited and say, wow, I'm just going to do this VFD conversion, hey, no problem. Well, yeah, you might have to consider cost. It's not cheap. So we've got our pulleys for the motor all figured out, it's all calculated, etc. So now we need to start taking things apart. And you could simply, take off the pulley. But why to do that? We got to remove the motor anyway and change it up for a 3-phase motor. So in order to do that, of course, you need to loosen that up right there. You need to take your belts off, and we need to disconnect the motor from the machine. And as you can see here, that's the cable that comes from this panel. So we just disconnect that in here. Now, none of that is going to be the same later because we're going to a 3-phase motor. But nevertheless, keep records of what's going on just in case. Once you got your electrical cables disconnected, and remember to unplug it from the wall, there are 4 bolts to take off from this plate, the motor mount plate, to get it off the milling machine. They are 1/2 inch. Okay, so now our motor's installed. That's no-brainer. I'm not even gonna bother showing that. I'll show all the connecting and wiring and all that stuff, but the motor installation, you can do that. Pick whatever pulley you want. I chose to reuse the existing pulley. I've just got a few plans, which I'll explain a little later in the video. Okay, so on this PDM-30, there's this cover here that covers this electronic control circuits. That's a contactor and a transformer, the emergency stop switch, the start switch. I'm gonna rip all this off and I'm gonna replace this with that. That'll be the E switch, the start switch, the forward, reverse, and off. And this here stop switch I'm going to replace with a potentiometer in order to regulate the speed at which the mill turns. The other set of wire we're left with is the one going to the outlet. Since I've removed everything, I certainly wouldn't be able to mount this. So I'm going to reuse this little mounting box here. I'm going to reattach that and show you just how the switches are going to be mounted. That's up again. I like that because it's kind of out of the way. There's room in there to bring in wires, etc. Anyhow, we're going to mount this right about here. So finally, be able to access the quill lock without any issues. She'll be able to navigate the wiring really nicely. Punch a hole in here, route it through, right the wiring through the side of this thing. So that's where that's gonna go. That's the basic physical layout. And I would suggest that before you start doing anything, like attaching, installing anything, that you actually come up with an actual plan for yourself. As far as the box placement that's gonna contain the VFD and the various electrical components, like the contactor, etc. I'm planning on putting that on the wall in a nice safe box. So you say, okay, well, what if you want to move your mill? Well, quite frankly, the mill, yes, is on wheels, and I'll just leave myself enough cabling to be able to service the mill if I need to. Now I'm at the bench and I'm doing the wiring part for my switches. So let me show you this thing again here. At the top, you've got the potentiometer that's going to regulate the speed of my spindle. This is gonna be forward and reverse. Middle is stop, of course. This is the start button. And so you know a start button should be wired as a normally open circuit. And only when you push it does it become closed. Closed means it makes contact. A emergency stop button is the opposite. It is normally closed. And then when you press it, it opens the circuit and stops the power from flowing through. Okay, so with that in mind, what we got here is two low voltage circuits. So these cables don't need to be big. They are only sending a signal to the VFD unit and its low voltage circuit board. Now these switches actually are higher voltage. They have the voltage that it actually supplies the machine. So therefore, these have to be separate. So, but before we go there, let's think about these here. All right. Now, these little cables that I used have 3 wires each. All right. And that's a nice combination because then you don't have to have loose wires coming around. Now, on a potentiometer, you have 3 posts. Okay. So, and they manage the signals, all 3 of them. So make sure you remember which color cable you're using. All right. And same goes for these. Now this here is the forward, reverse, and center and off switch. And these, see I made the lines here. So you've got, I'm using the bottom post as my negatives. All right. So that's on one wire. These are wired together. And then you have the white on the one side and the red on the other. All right. So this is not a course in electronics. I just want to show you how I'm wiring things. Now, the other 2 switches, I just want to note that these connectors that go in from the bottom on this. So if you have similar switch arrangement, make sure you leave them in a position where you can actually insert your connectors. All right. So that's, and also I've taken the time to mark what's normally closed and normally open. That way it's easier for me to actually remember. All right, so quick recap. I've got a trim pod here, all right, to control the speed. This is the direction, forward, reverse, and stop. This is a start button, and it is connected on the normally open side of the switch. This is the emergency stop, and it's connected on the normally closed side of the switch. Okay, so what I've done, as I mentioned earlier, I wanted the wiring to come out inside this thing here. So this is how, pardon me, this is how this is going to be, right? So now I've got to snag this through completely, and on the other side it'll be secured and to offer strain relief. And then we're getting very close to connecting everything else. So the next part is going to be configuring the box for the VFD, the breaker, and all the other components that are going to go in it. Okay, so instead of waiting to the very last minute to put everything together, I'm starting to do that as I'm going along. It'll just make my life a whole lot easier. So I'm going to mount this bracket with my switches right now. All right. It's kind of handy. The machine comes with these threaded holes already, so just take advantage of whatever you got. Now I've got the box on the bench. And I'm just getting things sorted out to make sure that everything's going to fit the way I want to. Now, take note, we have a ground placement here, the screw that's going to accommodate that. Here we have a breaker, the contactor, and a fuse, the VFD, and a filter. All right. Now, I'm not going to explain all the whys. If you want to know all the whys that we need all this, please go see Cloud42's videos. They're absolutely fantastic. Now, why is it important to get this all sorted out now? Well, quite frankly, we've got locking mechanism here for the door. You want to make sure that's going to fit. All right, so make sure you do that. Once that's done, James installed a filter here and a fan at the bottom. We got all these things lined up where we want them so that everything fits. Well, great. So now you want to mark where the holes need to be so that you can actually secure all that stuff in there. And then we'll need to drill some holes. So the other accessories that we need, of course, is the filter right up front here to let the air escape the box. Fan's going to get mounted. And that's going to go here. Again, they come in pack-up twos, not very expensive. So basically now what I need to do is carve out some holes here and here in the box, drill all of the holes for all of this equipment, and then we'll move forward. You're wondering, how am I going to cut a hole in this thing? Just get yourself a hole saw. Don't mess around. This is the nice, easy, fast way to do it. All right, we're back at looking at this box here, and as you saw earlier, I made those holes with the hole saw. My fan is installed, and I installed the grill and a filter on the inside next to the fan. So here is the filter for the front, and these are really handy. They're just magnetic, so you don't have to screw anything. Just slap it on, you're done. So that's really great. Now, how did I attach all of these components? Well, there's a rail, what's called a DIN rail. That's what is holding the contactor and all these other gizmos. Now, I've actually bolted them in, and as you can see here, I've got those bolts pretty well flush. You know, they only extend about 1/8 of an inch past the back, which is great, right? So that'll be against the wall, 4 screws holding into the wall, and Bob's my uncle. So now, where am I at with this? Well, I want to go install this on the wall before I wire everything in. That way I'll make sure I cut all the wiring to the length that I really need. This is where my wiring is going to come in, my cables. And I would have liked to do it underneath, but unfortunately the fan is interfering with that. So that's okay. I'll just use the side since my machine is on that side of the VFD panel. So let's go install this on the wall, and we'll go on from there. I've now installed the box on the wall. My mill is here, the plugs are there, my DRO's here. It just made sense to have it all right there. The other thing that I've done is I've run all of my cabling. So let's go to the mill and look at what is going on. You had seen me install this. There's the loop with all of the low voltage, high voltage wiring for the controls. And that goes 6 feet up to the box. Now, I've also run a cable, that's a 12-4, that goes to the hookups to the motor. I'm not hooking up things. I'll actually show you as I do it. So let's go back to the VFD box here. And here I've got my power outlet coming in, right? So these are the cables. I've already got the connectors for it. Just gotta install one on this one here. The low voltage wiring is all here. They're soldered at the end because they're just plugs that go straight in here into the VFD. The high voltage controls are the same thing. And so I've just soldered them to make them go in. The same thing is true for the wires that are going to go to the motors. And I've numbered them, right, by color. That way I can identify them at both ends without getting confused. So the next thing I'm going to do is installing all the grounds, and they're all going to go to one point, okay? That way you avoid having ground loops, which is a real bummer to try to diagnose. You've got one that comes from the outlet, needs to be grounded, so just pick this spot here on the VFD. The VFD is ground to the box. The filter is also grounded. And then the motor, this is the motor cable here, it is grounded to the motor as well. That's very important. So here at the motor, we have this ground that we just looked at in the VFD box, and it's gonna get grounded to that screw that's right back here. I now have the low voltage connections done. Hopefully they're correct. If not, it's easily fixed later on. Now, all that's left to connect inside this box are these 3 cables, which will take the power to the motor. White is 1, black is 2, and red is 3. So it's pretty simple. One goes in T1, 2 T3, 3 T3. Now, there is one more thing that we do have to do. He's inserted ferrites to reduce the amount of electromagnetic interference. I've now connected these cables that go to the motor, T1, T2, T3. And so what you do with these ferrites, you actually put a few around all the cables, then you put a few around each wire, okay? So that's how it's usually done. Now I'm gonna go connect the motor. We're at the motor, and this is a 3-phase, right? So I've got them numbered 1, 3, and that's assumably 2 because the sticker fell off. So all we're gonna do is connect the appropriate number, and then we're good to go, right? So we're feeding each phase is what we're doing. So let's remove these morettes. Okay, 1. So let's grab number 1. Twist the wires, take your moret, and she goes. Make sure it's nice and tight. Now that I've got everything installed and I've actually connected all my wiring, I'd like to mention that it's really important to draw out all of your circuits first on a piece of paper and double check everything. Now, one thing that I've learned in this particular project so far is that there are many kinds of contactors, and depending on your motor, the power that you're using from your outlet, is it 230 volts, is it 120 and whatnot, all of that changes absolutely everything. So in my particular case, I'm using 230 volts out of an outlet. I'll show you the plug again, like this. Now, what's interesting about this is that this is 120 and this is 120. There's no neutral. That there's no instructions out there that cover the connections to a contactor without a neutral. And you're left wondering, well, how do I do this? So I'm providing you with basically the diagram on how I've done this. So now you see how it's wired. And it's really not complicated once you figure out how a knee stop or a stop switch and a start switch can be connected together and then to your contactor. So the second part of the connections involved the control, the low voltage controls, which are the trim pot. See, I've marked them here. This one's a forward, reverse, and stop. And then, of course, the trim pot here that regulates the speed. And so these connections, you can sort of figure it out. If it's not right, you can change the wires, and then you figure it out, it works or it doesn't work. And then after that, you go into the programming of this thing. Now, there's some interesting aspects to pulleys when you're going to install your VFD that they're rarely discussed by anyone. Now, the usual setup in your milling machine is established here with this chart for the speed chart, right? And the belt. Now, if you're using high-speed steel and also carbide like I do, etc., you're drilling, but you're also milling, using large cutters, etc., this is pretty well the middle of the road right here, 706, 770. And your VFD, if you set it up like this, then your VFD at 60 hertz is going to run at this speed. Right? It's going to run your mill at this speed. Now, most motors, actually this particular motor, this Leeson, will easily run at twice that speed with the mechanisms that are inside, the bearings, etc. They'll take it, no problem. Now, double that, it's 1400 RPM. I've got my VFD set up so that it'll run up to 120 hertz, which means it can run right here easily, right? So actually it'll be higher than that, but so let's say I set it up like that, right, at 770 under the pulleys, and I can go at 120 hertz. I can get double that speed, and when I want to go really slow, then it's not going to be a huge problem with my motor, for my motor to do that, right? So I can lower the frequency and reach really low speed. Shouldn't be a problem at all. So that is one of the issues that you need to think about. Now, say for example that I had kept this pulley here for my spindle, and I'd gone to a pulley back here that was 1-to-1 to this. Well, that's lovely. The motor can go at 60 hertz, 1750 RPM. But what about lower? Like to go with the lower speed, you might not get a whole lot of torque and all that stuff, and it'd be difficult on the motor. So the speed range, having a good torque throughout the whole curve, then this is a pretty good setup. And the best part is you don't have to change pulleys. So, you just have to adapt the rear pulley, the motor pulley, to whatever motor you got, just like I did. Now let's do a quick review of what's in my panel. I've got my VFD, my contactor, an unused filter for now, and a fan. And of course, I've got the power coming in to the switch, which powers the fan, and then later on the tachometer. Now, the manual calls for having a breaker in front of your contactor and then fuses on the other side. Like, because there's live on 2 wires, then it would have to be doubles of each for my setup. Now I actually have the breaker and fuse on order, and once that's done, then I'll hook all this up and go through the filter. But for now, this works great, and that's essentially what the installers told me to do at emotorsdirect.ca. By the way, if you have, they don't sponsor me, but I did buy my motor from them and my VFD, and they're absolutely fantastic. They have videos online as well, so Should you wish to learn a little bit more about this stuff, you can view their YouTube channel. So here we are in front of the mill, and I've already activated the VFD by opening the emergency switch and pressing on the start button. So now I'm essentially ready to work. So forward reverse switch is on this side, and reverse is on that side. And here's my trim pot or potentiometer, which we like to say it, in order to control the speed. We already know that my belts are set up for 770, so when I reach 60 hertz, that's about where I should be. All right, so let's start the mill. Okay, now because this controls the speed, I'm activated, there's power on, but now this controls the speed. All right, so let's get it started. Let's start slow. Look at that 69 RPM, 60 RPM, that is just fantastic. Okay, let's keep going. And there you go. So let me check what the frequency is. Now, at 786 RPM, the frequency shows to be 56 hertz. So let's put it to 60. And this is the speed I get at 60 hertz. The pulley table is not quite in accordance with what is going on for real. And that's not uncommon. I mean, you get the same thing all the later. But it's pretty nice. I have never heard my mill be so quiet. This motor is going through the VFD is absolutely fantastic. I have no regrets. So it works. I've got it set up to stop within 3 seconds. And there it is, stopped. Plus now I have a reverse function, which is really, really great. So I think the last point I'd like to touch on is talking about what it costs to make this conversion. All right, time for the reality check. How badly do you really want to put a VFD to control your mill? The regular price of a 3-phase 2-horse motor from Leeson, $1,500. Your VFD, $450. Now this varies. You can get cheaper ones, but I chose to go with what's recommended for these motors by the company I bought from. And breaker, fuse box, contactor, all this stuff's pretty cheap until you get the electrical box. That's not cheap, 85 bucks. The cabling and all the accessories, you know, the plugs, all the stuff, that came to 200 bucks. The power supply for your fan and the fans and filters, that's about 45 bucks. So the total is $2,400. My mill cost me $2,500 when I bought it, plus tax, you know. So, okay, fine. So that cost me $3,000. So now I'm up to $5,000 into this mill. Definitely not getting rid of it anytime soon. So you really got to think whether or not changing some belts is problematic enough for you to actually invest in this modification. Now, of course, you can get motors that are cheaper than that. I've seen them float for about $400 in eBay, but you don't really know the condition of the motor. So that's, again, the dilemma. Do you want to pay $500 and take a risk that it's not really working? Then you got to upgrade the motor. That's really up to you. So with all that said and done, I'm very happy with the results of my VFD conversion. But to be honest, it's quite costly and it may not be for everyone. So before you jump on bandwagon, just make sure you count your pennies and decide whether or not changing belts is problematic enough for you in order to do this. I hope this video was useful for someone. I know it was quite challenging for myself. So I'd appreciate if you'd like and subscribe. It really helps me making more videos. And I look forward to your comments. Take care. Bye-bye.